Hello, everyone. I'm John Jeremiah with Traceable AI, and today I'm having a discussion with one of our product managers, Sudeep Padiyar, about the Log4shell exploit. You know, Sudeep, I thought you and Inan did a great job in the webinar explaining how the exploit works and a lot about how it can be detected and blocked. But I wanted to use a little time today to talk to you about how Traceable AI explicitly handles the attack and perhaps learn how people can use Traceable to help block the attack. Sudeep, could you talk a little bit and share a little bit from what you've been doing and what we're doing about how exactly does Traceable AI detect and block Log4shell?
Sure. So, John, as we all know at this point, right, the exploit is actually in a logging library, which is used predominantly by Java, but could be used in other places, right? So it's very, very prevalent. It's pretty much something which is running amok over the internet as we see today, right? So the mechanisms that you need to protect against something like this have to be very comprehensive. So at Traceable, our approach for defense in depth has always been around the fact that in a modern cloud-native application world, you have Nginx ingress controllers, you have Istio. So the gates are way too many, right? So we made sure that you can protect you there. Now, deeper down, as we've seen even in this attack, there was a 7-day window after which the vulnerability was detected, right? So that means there was exposure for 7 days where your attackers could have been all within your infrastructure. So what you clearly need is also a mechanism to be able to go and check against each of these applications on one, was there an exploit, and two, just block it right away. So that is the underlying approach that we've always taken at Traceable. And in this case, for an attack which is as prevalent as Log4shell, we are seeing that is paying dividends.
So when you think about this, about the exploits, and I think you might have a slide that you want to share too of putting it together, and this might be a good time to share some of those views, the visuals. But it's the idea of defense in depth has been one that's been around for a long time. The idea that if we can only block attackers by keeping them outside of and keeping bad people outside our data center was one view, and then we put firewalls to protect around the network. You were describing this earlier, where you talked about how it's a different model. Do you want to talk about that?
Sure. Yeah, John. I'm a bit of a history buff, so the first parallel that I drew was from history. As in, for hundreds of years, we've had walled cities, all through the world, right? Europe, Asia, parts of North America. So the key there is that if we go back to the same example, then it's thinking that, oh, I have a wall, so I can, hold everybody on the other side, right? But if somebody's already infiltrated in and you don't really know about it, like in this case, for a week or 10 days, then what is the real protection mechanism that you need, right? The only option then is to go and lock every door in every potential house inside that walled city. And that is unfortunately the approach that is needed for an attack like this, especially given the way the environments are structured today, right? As in, you have applications running in the public cloud, you have them running in Kubernetes, you have them running in serverless. So the amount of different ways by which these applications can be deployed are too many. So the one viable way by which you can actually provide protection here is by actually blocking at each of these applications, regardless of whether they're running in a private cloud or public cloud.
That's right. So
it's pretty much, sorry.
So like you're saying, it's defense in depth. It's about having locks everywhere and locking all the doors at some level, right?
Yeah, absolutely. And the parallel here would be these individual applications, right? As in, regardless of where they are running, given there was an exposure for 8 days, and now guess what? We are seeing a new variant of the vulnerability, right? That means that there might be other doors, which, as folks are working on, stopping all of these potential breaches, you also have to now consider another vulnerability which is coming in, right? So it's just going to go on. And as we are seeing different codes, this is not something which will be done by end of the year. This is going to take months to actually plug all the holes.
So given that it's going to take a long time to plug the holes, people are going to have to take separate steps and separate actions to provide some sort of air cover or some sort of a protection in the interim. Can Traceable help with that?
Absolutely, yeah. So I'll quickly give an example, right? As in from the walled city to an actual public cloud deployment. So, this is where we see a lot of our customers today, right? As in bunch of applications, whether it's Kubernetes or virtual machines, doesn't really matter. What is of essence here is the logging infrastructure, is the Java component, and even other scenarios where, in this example, you could be using Tableau and it's, off-the-shelf software, or you have a bunch of libraries that are coming from open source. They're all using Log4j for logging. So what you essentially are dealing with is a scenario where your attacker could come in, and again, back to the gate example, you have all these malicious payloads coming in. You can block them at the edge, right? But as you start going inside your application, and because of the exposure that we've spoken about, you really need a mechanism by which you can stop this at each individual application. And that is where a lot of the smarts that we built in the product allows us to do that by actually looking at the sequence of function calls and blocking it based on the fact that you now have a JNDI lookup actually happening in the application code, right? So that's what is extremely unique with the approach that we've taken, and all the deep tracing and telemetry that we have within our platform allows us to do that fairly easily.
So with deep tracing and observability, we're able to see the attack, we're able to see the malicious payload in the traffic as it goes to the application. Are we able also to block it then?
Yeah, absolutely. Right. So with or without the malicious payload, at the moment we see that the JNDI lookup is actually happening, we have an ability to block it right there and then, right? So this is what is extremely unique. You don't need virtual patching. You don't need to necessarily have to go through all the IaaS cycles to say that, hey, is this actually happening in the context of a malicious payload coming in? We know that at this point, the risk reward is pretty clear to say that anytime there's a JNDI lookup happening in a Java application or in any of these third-party applications which are using the library, it's really time to block it. The other key aspect is the whole big hammer, right? As in, again, if you hard stop something at the gate, or if you just block everything blindly, then you are having an application downtime issue, right? Here, because we are specifically blocking the logging call, it means that the rest of the application could function. And that's a choice you have, right? As in case of Log4j, you may not want to do that. But there are so many other vulnerabilities where instead of taking the heavy hammer and blocking all the traffic which affects uptime, you really have an opportunity here with that fine-grained control to say that, hey, let that logging call not go through, but the rest of the functionality or the business logic should still go through.
That way you're able to only stop the one part that's malicious, that one little bit, while the rest of the business functions normally and safely.
Absolutely, yeah. In this case, because of the severity, you may or may not want to do that, but think of any other vulnerability, right? That level of control is very unique with the approach that we took with both distributed tracing and the granularity at which we can apply blocking.
So how much effort does it take to go through the process of understanding what your vulnerabilities are and then blocking that? It must be, I'm assuming, at least when I think about it, it sounds like that could be really quite an effort to implement that kind of security.
Why don't I go through it, right? As in the proof is in the pudding. So let me go through that quickly and show that on how we go about this. I'll start off with how you will see Log4j shell within the product, and then I can show you how you can go about installing this, right? So right as in you come into the protect part of the product, this is popping right up that there has been Log4j JNDI exploitation. And it also tells you the attacker, right? As we saw with this attack, a lot of the traffic coming in was from bots, right? So we can actually tell you where the attack is coming from. In cases where we can attribute the user, we can do that as well. So you get information about the attack as well as about the attacker, which is very unique. The other is as you start getting into the events, you will start seeing more and more information about which specific endpoint did that attack happen on. Right. In this case, we are actually doing the blocking and returning a status code. So that ensures that there is no malicious activity or no remote code execution happening within the product. And then you get to see all the other details around that, right? As in, where was the user agent coming from? And the API token in this case is what tells you very clearly that because there's a JNDI LDAP, in this API token, there is something malicious, and it matches directly with how a Log4j exploitation can take place, right? So right there and then, you can see all the details about the attack, and in this case, we have blocked it effectively so that your application is not going to be impacted.
So Sudeep, this is great. This shows us the vulnerabilities. Do you want to tell me more about how do you go deeper with this?
Yeah, so as you see in this view, you have all the details with regards to the request and response, and you can actually tell based on all the data in here that this was actually JNDI LDAP call, which is going to cause that remote code execution. And then you can actually go and do all the deep forensics, right? So as you see here in this view, you can actually know the call sequence which has led to the JNDI lookup call and all the details around this, right? So if you look at the version, right, this is what is the most important aspect here. You know that versions 2.16 and higher have all the fixes. So just by looking at this information and the entire inventory that you can build with this information, you can know that, hey, out of the 200 instances of Java applications running in my environment, only 60 of them are running 2.16 or prior, right? So one, you get an inventory of where the exposure is. And the second thing is right here, you're looking at the JNDI lookup key, right? That's what I was explaining early on with the lock example, right? Right here, you can block this automatically. So you don't have to go chasing and creating block rules on all the different applications where you might hit this. So because it's all based on functional logic within the application, we are able to block this at the get-go and just do it for the lookup function. So this is where you can actually see the power of telemetry, open telemetry in this case, and how we use it for the security use cases at Traceable.
So let me paraphrase that. I want to make sure I got this right. It means that if of the 60 or so different applications that are in my environment, if 20 of them are vulnerable, we can only work. We can then focus our security and block just those 20.
Absolutely, yeah. And just where that lookup is happening, right? So you get that fine-grained control, so that first you do the filtering of the inventory to say that, hey, 20 of these instances actually have a vulnerable version of Log4j, and anywhere you hit those, we block it right at that fine-grained control of the logging call based on the function, which is the JNDI lookup in this case.
And one other quick question. I don't know if you said this earlier, but Traceable provides people a list of an inventory of all these APIs and all these different API vulnerabilities, right?
Absolutely, yeah. So if you look at the API endpoints view, right here, you will see all the endpoints which are in your environment, and then you can search them by the relevant labels. You can search them by the sensitive data. So this is the other aspect of the risk that is involved of a potential breach, right? And we've seen numerous instances of this, right? As in, it's happening to Apple, it's happening to Cloudflare. I heard earlier in the day it's also happening to one of the payroll companies, right? So there is financial information, there is a lot of critical information which is already being exploited, right? So if you can look at sensitive data, then you know what to prioritize, as well as you know the potential risks that each of these APIs carry, right? So some of our customers have thousands of APIs. And if you now have to go about fixing each of them, you have to start with a prioritized view so that you know which are the ones where my credit card information is flowing, or which are the ones which have financial transactions, or which are the ones which are involved in shopping carts, because that is going to impact your business at the end of the day. And having an ability to do that is extremely important to correlate all the different pieces which are required from a security perspective.
So I want this is all awesome and fantastic, but I want to kind of move to the big question, or the big challenge, which is, this is great. How do I do this for my application, assuming I don't have anything in place today? How do I get started to use Traceable to put in the security today to provide this kind of protection?
Yeah, that's a good point. And in all honesty, John, some of this we were, anticipating as well as something that we wanted to make sure that people can do it on their own. So we do have a free product which gives you all of this functionality. And the second aspect is to be able to instrument all of your applications directly, right? So we call it the the self-service part of our product, where any developer, a security engineer, a product security engineer can come in and do this by themselves. It's fairly straightforward. You see all the steps here. You have to install the platform agent. Then in this case, you will have the tracing agents in Java, and then you generate the API traffic, and you're good to go, right? So the platform agent, you can do it in Kubernetes, or you can do it in a virtual machine. Again, we give you all the details. You can actually see the progress of how the installation goes through. And the key aspect here is with the in-app instrumentation, which gives you all the power that we went over earlier, right? So Java being the case in point, if it's running in a Kubernetes environment, then we give you all the modern tooling so that, just based on the namespace that you want to protect, you have that fine-grained control of where Traceable will be deployed. You can annotate the deployments. And once you restart the deployment in Kubernetes, which again, all of these are very, very quick in a Kubernetes environment, you're good to go. In case you're working in a standalone environment, then it's just pretty much getting the the Java agent binaries and then running your application jar with it. Once you've done this, everything will then show up in the view that we were talking about earlier. You will see all the APIs in the dashboard. You will get to the details around what are all the different endpoints which have potential exposure to Log4j, and then you can do all the things that we went through early on in the conversation.
So what you're saying, very straightforward, very simple. It's relatively easy to provide yourself basic protection against Log4shell, is what I'm hearing.
Absolutely. Yeah.
Fantastic.
Yeah.
If people want help or need to learn more, what's your suggestion? Should they connect with us? We have a link for people to meet with Traceable. Can we provide additional help and support?
Yeah, absolutely. As in, if we are on standby here, we've been doing that ever since Log4shell has been out there. So we are on standby. You can reach out to us, book a meeting, or if you want to do it yourself, you can use our self-service product, and we'll also be publishing a guide, a handbook, which you can use with just the simple instructions that I went over. So even if you want to do it by yourself on a Sunday afternoon, you can do that, right? So the self-service aspect of the product is extremely useful for people to get this up and running by themselves, but we are always here to help in case you want any additional details. And our customer success team, our sales engineering team, our engineering team is all available to help out as needed.
Fantastic. Sandeep, this has been awesome. Thank you so much for the time and going into this with me and with the audience as well. We'll provide the links to how you can get the free access to Traceable for free online. We'll put the links there. We'll put the links for how you can book meetings and connect with us. And then the quick start guide, as soon as that's published, we'll also be updating that and adding that to the links as well. Any closing comments, Sandeep, before we wrap?
Pretty much we know it's tough times, right? As in, we've all been in the industry for a while. You know that this is, pretty much as big as it gets, right? As in, after shell shock in 2014 and SolarWinds, this is, as big as any of them. So it's really bad, and we are, trying to make sure that, all the different, capabilities in the product, as well as any additional guidance that you need to understand both the implications as well as how to go about remediating this quickly. All of the information is on our website, as well as we can help out on an individual basis. So tough times, but we hope we can get through this.
Oh, we will get through it
in the course of time. Yeah.
And we will get through it. And I'll echo what you're saying, Sandeep. At Traceable, we are absolutely here to be part of this solution and to help all of you protect and secure your applications. We know how hard it is. We know how hard your jobs are. I've been in the other side of the world, not the vendor side as of my prior life. I know how hard it is to keep systems up and running safe, secure, and stable, having been a developer and an IT director in my past life. So we are absolutely here to help. We're here to help and be your partners and to assist. If you have questions, please reach out to us. Sudeep, thank you so much for joining us today or joining me today, and the audience. Thank you for listening, and we look forward to helping you in the future. Thanks, everyone.